Rainbow platform and so on. So I'm really looking forward to this call. So please, let's give them a big round of applause. I'm looking forward to it. Thanks.
Okay, so thank you very much. My name is Andre. I'm working in Alcatel-Lucent Enterprise. And for today, our agenda will be the first step. We will introduce a little bit our project and Janus context in our project, just to present you another thing, Janus implementation in the context of unified communication solution. The second topic, we will speak a little bit about orchestration. The third one will be traditional telephony in conference, because as you know, maybe we are working in Alcatel-Lucent Enterprise, so it's a big company, telephony company with 100 years of history. So we have a lot of legacy hard telephony stuff like telephones, PBX, etc. So we will present how we did integration of WebRTC stuff in such environment, and the last topic will be some of our contributions in Janus source code. I'm Andre. I'm R&D director of Alcatel-Lucent Enterprise Cloud Business Division. So we are working on Rainbow product. So what is it, Rainbow? Rainbow is not yet a unified communication solution. It's a kind of a relationship machine. So we try to build a social graph with some links between users. So people, bots using text and voice, and also with some IoT devices, and to bring them a new experience of communication, and also some important integrations with Salesforce, Microsoft, Google, etc. But we have also a lot of UC stuff in our solution. So we have group messaging, audio video calls, file sharing, conferences, some this phone control, channels, bots, Microsoft integration, etc. So why we had chosen Janus about 2.5 years ago. So just maybe a few words about the philosophy of our product and how Janus suits in this philosophy. So the first one, we speak a lot about horizontal scalability. So our services should be quite elastic and to be scalable up to 10 million of users. So with the orchestration of Janus, so we could easily reach this goal. The second one, we are working a lot with microservices. So all our services, mostly all our services are microservice. And so Janus could be easily integrated with a lot of rich interfaces that it provides in real life. The third one about API. So for a modern solution, we need to have a API almost for every action. So Janus provides a very rich way to be integrated in almost every solution with WebSocket proprietary protocol with REST interfaces, MQTT, etc. The third one, it's about flexible integration. So in our system, we have a kind of scalable message bus. So we, with the help of some microservices, we need just to plug some new components and to have new services. So Janus suits perfectly well in this conception. The first one, it's about media. So it's a main channel for today for human communication. So and this is why we need to have something to build a communication solution. So Janus suits also perfectly well in the domain of modern media, especially with WebRTC context. But we can't forget our saying past life with telephony and PBXs. So we provide richer, flexible integrations with some legacy stuff, and you could easily do some calls between old legacy systems and new modern WebRTC context and domain. The thing about artificial intelligence. So it should help us to make our work better. So we support it completely now in terms of several bots integration, text and voice bots, and also we started to do just several prototypes for Janus in terms of intelligent local analysis. But we will think about some interesting scenario with voice bot, voice assistant in Janus video and in Janus audio conference with some screen sharing, etc. And last month we have a great team of developers that like to prototype, to build new things, and Janus guys are also very cool guys, liking prototyping new things, building new systems, and we like them very much. Just to give a small context about our technical challenges, it's a cloud system with multiple data centers, and our users are distributed all around the world. The second one, as we speak a lot about media, so we need to provide the best quality of service that we can. In terms of saying network bandwidth and latency, and with some firewall conditions, taking into account that we have our users almost everywhere in the world. Like a Janus, we could present think our product as a product with two faces. We have a UCaaS face, and we have also a CPaaS face. So all our products, all our things are available either via SDK, either via REST APIs. And here, if for UCaaS users we could predict workload on our media components in CPaaS, it depends. It really depends on product. So we should be ready to address a huge amount of persons with some lucky guys that have written some interesting applications. And also we need to respect GDPR, sure. And some other privacy laws by keeping the necessary information only in a few data centers, and not to keep all the information across the world. So in our solution for today, we have two types of services. We have microservices, call it stateless services. So it's just some REST API requests that we could do, and after that we gather some context either from a message bus, either from database. We execute this request, we give the response, and after that there is no context. So it's not the case of media part, because we need to treat security handshake if it's a conference. We should have a conference context, media context, etc. For this part, we use a pattern with Orchestrator. So we need to to give a user the best Janus instance for doing a conference. So in our architecture, firstly, a user that would like to start a conference, he issues an API REST request in order to start the conference. So it goes to conference microservice, and after that we ask another geolocation microservice to find to localize this user using his geographical user using his IP address, and after that we try to find the best Janus instance that will be the nearest from a geographical position. So we ask about it our orchestrator. So our orchestrator has a list of Janus instances installed also all over the world, and also this component he makes some kind of pings of Janus interface and as well of our microservice interface in order to provide not only the nearest component but the component that doesn't have any technical problems. And so after that the conference could be started. So if we will take the architecture of this component, so this component has a resting point, so our operational team could easily add Janus instances and also delete unnecessary Janus instances depending on workload. So we will use Kubernetes soon for such operations. So we have also ping model in this orchestrator that helps us to find not only the nearest instance but the instance that could answer on Janus administration interface and also on our own interface, because it's necessary if saying you have some problems between the data centers, if some data centers are not ready yet or something like this. So we need to give not only the nearest instance but also the instance that is working. And we have geolocation interface. It's just to calculate the distance between user IP address and to find the nearest instance. So this is component written in Go language, so it's quite simple component. For the next that we have started recently, we will try to predict our workload because for the now it's statically allocated all the instances, but we would like to allocate it in an automated manner. So we will analyze some customer behavior, the things that we could do at least for our UCAS users, and also to gather more statistics from Janus in order to to predict next big conferences and to place it on the to optimize a little bit our Janus services allocation and to place it as closer as for existing conferences as we can. And after that, we would like also to try streaming. We didn't try it yet, so to have distributed Janus conferences when every user is. So if we have a user in Europe, either user another one in North America and another one in Asia, so to connect them on local Janus and to have some kind of mesh between Janus instances. So the next speaker will present the integration between our classical telephony model and also WebRTC Janus part.
Hi, I'm Claude JAEGLI, and with Daniel Bertrand, we are developer in the cloud business unit, and we will present you one of our projects using Janus. So, like we said before, so we are in Rainbow we have still a solution for make conference, but WebRTC conference. But historically, Alcatel-Lucent and Enterprise is a company who sells PBXs, plenty old PBXs with legacy phone with SIP phones, and we have now to integrate them. The solution for our architecture. Of course, Janus in the middle. And on the left side, we have our client, on a Rainbow client, using a WebRTC, the Tolkien with Opus decoder. And on the left side, we have our PBXs, who Tolkien SIPs mostly, who CANPOL SIPs, and also with all the codecs like G711 or G722. Now we have to integrate them, or to connect them better. And to connect them, we have we call it a Janus gateway. It's a Node.js server who interfaces with Janus to bridge these both worlds together. And we will present you a briefly call flow how this will work. Daniel?
Yes, here we will see in more details what we call the dialogue in conferences. So the possibility for a user to choose a legacy phone like SIP or PSTN phone and to use it to talk to the other persons in the conference. So the call flow that I will show you it's quite detailed, but we will focus just on some parts of the Rainbow architecture. Of course, Janus. And Claude just talked about it, the Janus gateway, which will be the interface between the Rainbow clients. This can be a web client, iOS or Android. And on the other side, the soft switch that will manage the SIP phones. Also, we will come to that a little bit later. There will be transcoding between the WebRTC world with the Opus codec and the legacy world RTP codec. In our case, it will be G711. Okay, first part of this call flow. So some colors, because I will show you the mixing between three codecs. It's the audio codec, the audio bridge, the video room, and also the SIP codec, the SIP plugin, sorry. So on the user, on its Rainbow client, he will dial the number that he want to, the number of the phone that he want to use in order to speak. So that's a request with that we call join. It includes the phone number. So I didn't present it here, but of course we are creating a session. We are creating handles in order to attach this, the audio and the video plugins. What is interesting here, it's that also we attach the session to a SIP plugin, so we receive a SIP handle, and this will allows us to create after that a link between the audio bridge plugin and the SIP plugin. So with that's the purpose of this SIP handle. What we are doing after, it's of course to register the SIP handle. The register will physically go, so it's a SIP register towards the soft switch. And after this, we will join both rooms, so the audio room and also the video room. In fact, video room can be used for the video and also the screen sharing. Just a few words about this register towards the soft switch. It can be removed, and in fact, we will have to reconsider it once the SIP trunking will be available on a Janus solution. So once we receive the response from the soft switch, so it's registered, we can start the SIP call. So it's the message call that we are sending with the SIP handle. This will send an invite towards the soft switch. So what's really important here is to notice that this invite has no SDP. It's an invite without SDP, which will go to the soft switch, and of course the SIP phone. Here I'm presenting a SIP phone, but the soft switch can be connected to our Alcatel PBXs, and then use our legacy PSTN phones also. So that's a normal SIP call. So you see the 100 trying, the 180 ringing. Of course, on the client of the user, you will see the call evolution. Okay, so the phone is ringing. Once the user takes the call on the phone, so 200 OK is coming, and so we receive, and Janus sends us to the Janus gateway the event incoming call. So it's the callee SDP, and in fact not really the callee SDP. Janus, the ICE module has changed several things, because we will find here the ports of Janus inside. And once the callee SDP received, we will configure the SIP module with we will configure the audio plugin with the callee SDP, and as a response, we receive the Janus SDP. So here you see the benefit of the invite without SDP. It's Janus who will decide which codec will be used. So once the Janus SDP received, we send it towards the SIP phone in the ACK transaction. And then, of course, the exchange of audio parameter is done through the SIP offer answer module. So Claude, I'll let you continue with some contributions.
You see the call flow before, that we need to have an invite without SDP. This is to let us to decide what we can take from a codec. So we had now to, when the audio bridge is make a mixing of the WebRTC world. So we have Opus codec on one side, and on the other side, on all PBXs, we have mostly no Opus. So we had to make a transcoding between a G711, who you have on all PBXs, and Opus. And this transcoding, we integrated it in the Janus plugin, in the SIP plugin, to bridge the media. This was the first contribution. And after we see also that we need to have an invite without SDP. This is to let us to decide which codec we must use. Janus is in fact a client SIP user agent, so we had to change it, a little bit to be able to send an invite without SDP. And this is also a modification in the SIP plugin.
And some more contributions which are made by Eric Bramoulet, which is the fourth guy of Alcatel Lucent who came here, and which is in the assistance. So first contribution is the forward error correction, which is done for the audio bridge plugin. So this contribution is available in Janus currently. And so here you see on the graphic the benefit of this forward error correction. Second, it's at the end of the communication. That's not available currently in Janus code. It's the sending of the mean opinion score, and that's sent at the end of the call, in the end call message. So that's all for us. And just thank you for the invitation. And it's really great to be in Napoli. Thanks.
Thank you. Thanks. Do you have any question for the? Okay.
Thank you. Thank you for the presentation. A question about, if I understood correctly, you added capability to send invite with no SDP out, right?
Yes.
Yeah. Yeah. So is it also possible to receive for incoming call invite with no SDP, or it's not?
It's also possible to receive an invite without SDP.
Oh, okay.
In the call flow, we show maybe we had an outgoing call, but we could also add an incoming call to the audio bridge. So we need the same invite without SDP.
Okay, and question, if you looking forward to add this flexibility with delayed offer to extend it to like other plugins, or it will be more challenging? I mean, normally Janus has like strict rules in which plugin you need to send SDP and in which plugin you expect to get SDP offer back. So if you have it for SIP, maybe you will look forward to add it for other plugins as well. Thank you. Anyway.
Oh, okay, thanks.
Okay.
As you said before, your user always find the nearest server to talk to. So that must be the case that your Janus instances should talk to each other somewhere. I mean, some kind of geographical cascading. So how did you do that? So, do you understand my question?
No.
So
Frankly speaking. Sorry.
So
Yes.
I mean, your user send the media stream to the nearest server,
Yes.
and so in order to add that media stream, that stream needs to be sent to the other Janus instance, right?
Yes. So for the now, how does it work exactly? So we have multiple data centers. So for example, for the now, if we have one user in the United States, second one in Europe, and third one in Japan, for example. So if it's European user that starts the conference, so we start the conference on European Janus instance. But we have some kind of think light data centers all around the world. So the media in this case will go to a local data center for saying, for example, for a Japanese user, it will be in Asia, and after that, via some dedicated channels, it will go to European data center. So it will be, it's not the full pass around the globe that the media will do for such user. It will be sent via dedicated channel. So.
Okay, and can you describe more a little bit about that dedicated data channel?
Yes, so it's a quite of think it's not data channel. It's quite it's think some technical channels between our cloud data center providers, because if we speak about media, we should have for such channels some dedicated quality of service and some guaranteed bandwidth. And it's just a kind of it's a kind of some agreements between cloud data center providers to have such a kind of dedicated data channels.
Okay, okay. And second question is that, as you said before, you did AI with the audio and video stream, right? Is that right?
Yes,
yeah.
yes.
So did you face some challenges in doing that? Because in our case, we face some challenges like how to synchronize between the audio and the video stream. So sometimes the audio came earlier, sometimes it came later, and the media, the video stream, each frame is separate, is split into so many RTP packages, and how do you combine it to make an entire frame?
So it's it's a quite a huge topic. I'll propose you to contact us during maybe lunch or this evening, so we'll discuss it. So it's quite difficult to explain in several minutes. So
okay,
please contact us.
Okay, thanks.
Come just back to your first question, how we locate the nearest servers. If you have a client in the world, we use a GeoIP database who gave us approximately the location, and after we are looking simply for our nearest data center. So the IP address is the root ID for the geolocation.
Thank you for your speech. And so my question is that you mentioned that you are using audio mixture for PSTN clients, since that's a necessity, since they can accept only one stream. But have you ever considered using the same audio mixture for usual web clients, since you've told that forward error correction provides better quality when using a mixer? Thank you.
It's the fact for the video, or it's the forward error correction for the video, your question?
Okay, okay. Yeah. You've said that you are mixing the audio for PSTN clients, for usual phone clients, and using the forward error correction mechanisms, it allows you to get better voice quality. But so this is only for PSTN clients, but for usual web clients who join from web interface, do you use audio mixture, or you just forward your streams?
So the fact the forward error correction is for Opus codec, so it's also on the WebRTC side, not only for the PST side.
I think that we have a mixed conference, so almost statistically almost all our users use usual WebRTC connection, so where is no telephony stuff. So in this case we use forward error correction for such audio experience. And as it was presented by Daniel and Claude, so we have a little lag to see plugin in order to connect our classical stuff, and in this case, so we use forward error correction also, but with G711 codec. So, but in the worst case, we use forward error correction, so in the same conference. Because we have a mix usually between PSTN users and some WebRTC users only.
Any last questions for our speakers?
Yeah, thank you for your talk. And I was wondering about the transcoding issue that you have, because most people have it and we would like to avoid it. So have you thought about enriching maybe audio bridge plugin to accept more codecs, or maybe building your own PCMA only mixing room or something like that in that order, if the other side is not allowing Opus at all?
think it's a kind of philosophical question that we like a lot, and we have had also discussion with Lorenzo about it. For the now, yes, we do some transcoding on Janus part, and we understand that it's not very it's not maybe the better way to do it, but in our current architecture, it's the better way to put transcoding. So we did some CPU and memory efficient implementation for that, and for now we didn't see any saying performance drain or memory drain in this code part. So it's just a choice so that we did.
Okay, any more questions? Or okay, another big round of applause for our speakers then. Thank you.
Thank you very much.
And now it's time for our lunch. So the lunch we'll have to go